Hi everyone, I am Priyanshu. Welcome to the South Education Academy. So in today's video, we are going to talk about our class 10th mathematics chapter 2 sets, and this is our lecture number 2, and in this today lecture we are going to discuss about types of sets. In the previous video, we already discussed about our exercise 2.1, and in this lecture 2 we are going to discuss about types of sets like empty sets, subset, union of sets, interaction of sets, disjoint sets, and difference of sets, and universal set, etc. Okay, so today's video is going about the types of sets only. Okay, so let's just start this one here. So when you come to the here, our first set is empty set. What is the empty set? So actually we can see the definition also. Empty set means a set does not contain any element is called as empty set or null set or void set. Okay, we call empty means is it a blank, nothing in this one, it doesn't contain any number or element. This is our empty set. Okay, empty set is denoted by this or these two brackets, and in this two bracket there is a nothing element. Okay, I will explain you. Let's suppose if I tell you empty set means what, it is a one type of set. In that set it doesn't contain any element or any number or any alphabet, it is just a simple. Let's suppose this is a 2. Okay, this is a not a empty set. Why? Because it's containing the element 2. But if it is a blank like that, in this one it is an empty set. Yeah, it is an empty set. Okay, so for understanding purpose it is clear, and we can denote empty set like this also. It is also a symbol of empty set, or we can represent like this. Okay, is it clear? Right now let's do some question to understand the empty sets. Like that, if I ask you, a question is given, the set of integers which lies between 2 and 3. Okay, which lies between 2 and 3. Okay, between 2 and 3 any number is there? No. Any other number is between 2 and 3? No, any other number is not given in between 2 and 3, so it is a blank. Yeah, so this is our empty set. This is our empty set. If I tell you set of integer which is lies between 2 and 4, 2 and 4, in this one it is an empty set? No, because in 2 and 3, 2 and 4 there is a one number of between, that is the 3, so it is a not a set, right? Like that, here between 2 and 3 any other number? No, there is a no number. There is a no any number, that is not existable number. So it means that it is our null set, or you can say empty set or void set. Okay, is that a clear? Empty set means it is a blank set which doesn't contain any element. Okay, let's take another example. Let's take another example. A set of natural number that are the smaller than 1. Set of natural number that is smaller than 1. There is any other natural number which is a smaller, which is a smaller than 1. Okay, a smaller than 1 is smaller than sorry, this question is only wrong. I will write here. Okay, if the set of natural number, okay, n means natural number only, you have to understand, natural number that are smaller than 1, is it our empty set or not? Natural number start from 1. Okay, so it means that there is no another smaller number than 1, so it is our empty set. Why? Because it is not exist. It is not exist means it is our empty set, because there is a nothing number which is, there is a nothing natural number which is less than 1, so this is our empty set. This is our empty set. We can represent like that or like that. This is our empty set. Like that, if I ask you second question, set of odd number that leave remainder 0 when it is divisible by 2. Okay, the set of odd number is 1, 3, 5, 7, or that's the 9 and 11. If you divide this number by 2, will it leave the remainder? Yeah, it's leave the remainder. It means that it is our empty set or not. It is our empty set because it doesn't contain any element, because this 1 is not going to be divisible by 2. This 3 is also not going to be divisible. Like exactly, it is going in points. Like here 3, if you divide 3, it is going to divide by 1.5. Okay, in point it is going to be divisible. Without exactly divisible, it is not possible. So it does not exactly divisible by 2. Okay, like 5 also not divisible, 7 also not, 9 also not, 11 also not. So it is not possible. Okay, if you divide this odd number by 2, it is not going to be divisible. It doesn't have any element which is going to be divided. So it is our null set. It is our null set, or we can call empty set. It is our empty set. It is clear? I hope you will understand the empty set. Empty set means which doesn't contain any elements. Okay, I understand the empty set. Is it easy, right? So let's move to our some other types of set, like universal set. Okay, let me I take a break here. Okay, right, so we have to write here, we are going to discuss about universal set. Okay, that's the universal set is very interesting because you can see in your textbook also. Okay, right, universal, UNIVERSAL, universal sets. Okay, so let me I write a definition of a universal set. Okay, so what do you think about the universal set? Okay, universal set means what? Let's understand the universal set by the example, then I will tell the definition. Okay, so a set which has element of all the related set without any repeating of elements. Okay, it is a set of element which is not going to be repeat. Let me tell you, let's see example. Suppose this is a Ram, okay, and here it is Sri, okay, and here it is Rohan. Okay, this is our one set. This is set A, and set B, it is a Rohit, okay, and here it is Sita, and here it is Geeta. Okay, this is our set B. So how we represent this set? So when we represent AB, it is represented, universal set is always represented by this U. Remember, universal set is represented by U. So we can write here U equals to, and here we will represent this all number like Ram, Sri, Rohan, Rohit, Sita, and Geeta. When we represent this all number, this is called universal set. Universal set means what? A set which has element of all the related set without any repeating. Okay, so this is our definition. So let me write a definition, then I will give you an example to understand more better this about the universal set. So the definition of universal set we can write with me also. So a set which has element of all the related sets without repeating. Okay, without repeating. Okay, repetition, or you can say a repeating of element. Actually my handwriting is something bad. Okay, you understand? In the universal set we write all the elements of the sets, okay, without repeating it. Okay, let's example. Let me I tell you example. Let's take an example, and universal set is represented by U. Okay, example, this is a set A. In this set A there is a given 2, 4, 6 and 8. Okay, and this is a set B. Okay, this is a set B. In set B it is given 1, 3, 5, 1, 3 and 5. Okay, so how will you represent this? We can represent like this. We can represent like here, U equals to here 1, 2, 3, 4, 5, 6 and 8. This is our representation of universal set. We write all the elements of both A and B in a one way. Okay, we will write set of say we will write the all the element of sets in one proper manner. That is our universal set. Are you understand? Okay, if you understand, that's good. Let me take another example. Example number 2. Okay, let me tell. This is, suppose this is A, this is 1 and 2. Okay, and this is B. Okay, B is like 3, 4 and 5. Okay, and this is a C. C is like 4 and 5 and 6. Okay, in this one, how will you write the universal set? Universal set is U. In this one, let's see, there is a 1, 2, 3 and 4. Here 5 is a 2 times, 3 4 4 also 2 times. So we don't have to write 2 times, we have to write only 1 times, like 4 1 times and 5 1 times and then 6. Okay, this is our universal set. Universal set means what? When we write the elements of all the related set without any repeating of the element. This is our universal set. Okay, so I hope you will understand the universal set. Then let's come to the understand the subset. Okay, so let's see the subset. Okay, so here I can write subset. Okay, subset. Okay, right now we are going to understand the subset. This is a very easy. Okay, don't worry about it. What is a subset? Because of the, okay, before I'm going to write this subset, I give an example. Okay, if I give an example, and always remember, subset is representing by this of this. Okay, represented by this bracket. Okay, representing by this. Subset is represented by this symbol. Okay, if I give an example of subset means, then you will understand. Okay, let's suppose if there is a if there is a element A, there is a one set A. Set A is given, and the element of set A is 1, 2 and 3. Okay, and here is a set B is given. In this set B, the element is 1, 2, 3 and 4. Okay, so am I asking you, is a set A is a subset of B or not? Is set A is a subset of B or not? So it is not. We can write set A is a subset of B or not. If you see, whatever the element of A, is it present in B? Is it present in B? Yes, it is present, because 1 2 3 in the set A. In this set B also 1 2 3 is there. So it means that it is a subset of B. It is A is a subset of B. But is B is a subset of A? Is B is a subset of A? Let's see. Whatever the element A is there, 1 is there, 2 is there, 2 is 3 is there, 3 is there, but 4 is there. In B set, the element 4 is there, but in set A, the 4 element is there. No, it is not given. So it means that it is not our subset. A is a subset of B. Okay, A is a subset of B, but B is not a subset of A, but A is a subset of B. So what we understand with this is our subset. The definition of subset is that set A is said to be a subset. Set A is said to be a subset of set B. Okay, A is just said to be a subset of B when, if whatever the element present in set A, if it is also present in set B, then it is called a subset. Are you understand? Okay, if you understand, then it's better. If you didn't understand, then don't worry, I will explain you also. And so let's see, first of all, I write the definition. Okay, so don't worry about it, this is a very interesting chapter. Okay, so we can write here the definition. Okay, set A is said to be a subset of set B it is. Okay, set B. Set A is said to be a subset of set B if all the element of set A of the element of set A present set A are also present in set B. Okay, in other word we can say set A contain inside set B, or in other word, okay, another word you can say set A contain all the element of set B, then it is subset. Okay, it is not necessary that it is going to ask you like that question only. It is going to be asked, it's set A is a subset of B or B is a subset of A. Okay, it is understand. Let me give example. The example is like here, it is given B is given like 1, understand with 1 only, then you will understand. Like 1 is given here, okay, 1, 2 and 4, and here it is given B is given like 1, 2 and 4 and 5. Okay, so if I ask you, is A is a subset of B? Is A is a subset of B? I'm asking you A. Whatever the element is present in A, it is also present in B, then it is A is a subset. So here 1, 2 and 4 is given, 1, 2, 4 is given, it is subset. So we write here like that. It is A is a subset of B, because whatever the element present in A, it is also present in B, so it is our subset. But if I tell you, is it a B is a subset of A? Whatever the element present in B, is it also present in A? So let's see. Here is 1 is there, 2 is there, 2 is there, and 4 is there, 4 is there. But the 5 is not given in set A. So here we understand that the B is not a subset of A. B is not a subset of A. Why? Because in the B, whatever the element, there is a 5 elements. There is a 4 elements, 1, 2, 4 and 5. It is not present in A. So it is not a subset. Okay. Is it clear? Take another example. Example number 2 here. This is a B, C and D. Okay. Here it is A given. Okay. I'm asking you, here B is given like, A, E, don't write this. We can write here. Let's wait. Okay. Here given A, and here it is given B, and here it is given C. Okay, right. If I ask you, is A is a subset of B, because whatever the element present in A, is it also present in B? Let's see. A is given, B is given, C is given, but D is not given. It means that A is not a subset of B, because A is not a subset of B. Why? Because whatever the element in A, it is not in B. Okay, so it is not a subset. But if I ask you, B is a subset of A, let's see. Whatever the element in A, like whatever the element in B, A is there, B is there, C is there, then whatever the element in B, it is also present in element C. So B is a subset of A. So B is a subset of A. I hope you will understand the subset. Okay, I understand. Then one more important here. One more important note for you. Important note is that null set. Nulls means this one. Okay, we can say this one, or empty set or null set. This is called empty or null word set. Is a subset of every set. Example, let's suppose here null set is given. A is null set, and here B is given like 1, 2, 3 and 4 is it given. Okay, I'm not writing well here, so I will write again. Suppose here it is given 1, 2, 3 and 4. So I'm asking you, set A is a subset of B. Yes, because whatever the element in set A, it's also present in B, so it is a subset of this one. Okay, otherwise B is a subset of A. Yes, because whatever the element in 1, 2, it is also present in this empty set, so it is also subset. Okay, always remember this one. And every set is a subset of, and the second is important thing is that every set, okay, every set is a subset of itself. Like how? Because this is a subset A, like 1, 2 and 3. Okay, I'm asking you, its set A is set A is a subset of set A? If I ask you, set A is a subset of A? Yes, because whatever the element in A, it is also present in A only now. So it is a subset. Okay, like this is, suppose A is given here. Let's suppose here, like a number is given. The set C is given, like A, B, and C. Okay, and the handwriting is not cool here, so I will take another pencil. Like suppose here it is given set 2. Okay, set 2 is given A, B, and C. I'm asking you, is set 2 is a subset of 2? I'm asking to you, is set 2, okay, is set 2 is a subset of 2? Yes, because whatever the element in 2, it is also present in 2. So this is our set. So remember this two thing. Null set is a set of everyone, and every set is a subset of itself. Is it clear? Right. So if it is clear, and then do this is there. Okay, let's do a something question here. This is question for you. Okay, it is a do this. Okay, do this in page number. It is a given in a page number. Okay, page number 37. Page number 37, it is given. Like question number A is given here. A is here given 1, 2, 3, and 4. Okay, and B is also given. B is given 2 and 4. Okay, and C is also given. Okay, so we have to write C here. C is given here like 1, 2, 3, 4. Okay, 1, 2, 3, and 4, and 7 is also given, and 7. Okay, and D is given. D is not given. F is given. Okay, F is given. This is a null set. Okay, this is a null set, and it is asking that, the question is asking that, question number 1 is that, is set A is a subset of B? Is set A is a subset of B? Let's see, whatever the element in set A, it's also present in B. 1, is it not present? 2, it is not present. 2 is present. 2 is present, but 4 is also present, but 1 and 3 is not present. So it means that whatever the element in set A, it is not present in set B. So this is not a subset. So we can write like that. It is not a subset. Let's do question number 2. Question number 2 is telling that C and A, whatever element present in C, is it also present in set A? Whatever the element present in set C is also present in set A. Let's see, 1 is there, 1 is there, 2 is there, 2 is there, 3 is there, 3, 4, 4 there. But in set C, 7 is there. But in set A, 7 is not there. So we can say that set C is not a subset of A. So it is also not. Okay, question number 3, let's see. Question number 3 is that C, B and 1. B and A. If whatever the element in B, it is also in A. Yes, 2 and 4. 2 and 4 is in A. So we can say that set B is a subset of A. Okay, is it clear? Right, like that we can complete this one. Okay now, so I already explained you do this also. So let's move to the topic number another. This is a Venn diagram. Venn diagram is a very easy, nothing. We have to just take a box and in this one. Okay, so I'm not going to tell you Venn diagram because it is going to be something longer, and this is a very one. Okay, in this one nothing, I will explain in another video. We have to just take a box in this one, and whatever the element is there, common element write in this one, and non-common element write in this one. Okay, if I tell you types of elements, then you will understand. Okay, right, so let's talk about here union of sets. Okay, another question is coming, is that union of sets. Okay, union. Okay, union of sets. Okay, so let's talk about union of sets. What is union of sets here? Okay, so the definition of union of sets is that union of sets is representing by symbol. Okay, it is representing by U. Okay, this is representing by U, and the definition of union of sets is, okay, let's move something. Okay, the definition of union of set is that, let me write first definition only. The set, the union of A or B, A and B, you can write A and B is, okay, is the set which which consume or content which we can write consume of all the element of A or B. I know you didn't understand by the definition. What do you understand by the definition? The definition is telling that union set means what? It is a set which contain all the element of A and B. A and B. It is contain all the set. The union set, there is a two set, A and B, and the set which consume all the elements of A and B. It's contain all the elements of A and B. Suppose example, let's take an example. The example you can take, this is okay, it is represented by U, we understand, right? This is a 1. Okay, let's take, this is a is given 1 2 3 and 4. Okay, and B is given here. Okay, B is given 4 5 and 6. Okay, it's consume all the elements of both of them. It's contain A U B. It means that it is write all the elements which is present, like 1 2 3 4. 4 is 2 times, don't write 2 times, only 1 time. That's 4 5 and 6. It's contain all the elements. Okay, so you will confuse in universal and this one, so don't worry. Universal is always different sets, but here it is same. Okay, and the another example is that, suppose A, let's write here. Okay, another example is that, like, suppose this is A and this is A, B and C is given. Okay, and this is O, and O is like it is also A, B, C and D. Okay, then how will you write this one? So we can write A union B equals to A, B, C and D. Why? Because A 1 time I'll written, B 2 times, but we have tried only 1 times, C 2 times, we have tried 1 time, and D is this. Okay, so this is the union set. Okay, did you understand what is the union set? Union set means what do you understand? It's write common elements only 1 time. It's write all the common elements only 1 time. So this is our union set. The union of A and B is a set which consume all the elements of A and B. Is it a clear? Okay, right. So interaction of set, it is a very easy, you don't have to be worried about it. So interaction of set, it is represented by this symbol. Okay, interaction of set, it is representing by this symbol. Okay, this is not A, it is a ulta U, you can say. Okay, and right now, what is the definition? Interaction set is very interaction, when two things is meet each other, that thing we have to write. Okay, like suppose this is A, both are same, so we have to write same elements only. In interaction set, we have to write same element only. We don't have to write which element is matching together, which element is same. We have to write the same elements, right? Example, if I tell, let's suppose this A is given. A is 1 2 3 and 5. Okay, and B is given here 1 5 10. Okay, in this one we have to write intersection set, intersection of A B. In this one, which set is matching? 1 is matching, same, 5 is same, so we have to write the same. So this is called only interaction set. When we write the same number of element, then it is called as interaction set. When we write the same number of element, is it called as the interaction set. Let's give another example. Interaction set example is there. We can write, okay, 1 2 3 3 4 5. Okay, no, it is a very old. Okay, let's take another example. This is A. Okay, in this A, this is A, B, C, D. Okay, and this is B is given. In this B, it is given A, E, I, O, U, D, F and C. Okay, in this one, which we have to write the interaction of set, which is intersection in this one. So here we see that A is A both in this one, we have to write. B is there, B is not there, we don't have to write. C not there. C is there. C is there. We have to write C. D is there. Yes, D is there. Okay, where we are going. Okay, we have to write the D also. Okay, we understand that in whatever the element is same, that is called interaction of sets. We have to write in the interaction of sets. What we have to write? We have to write the same element of sets. So the definition of the set is that we can represent interaction of sets by this one. Understand? So right now the definition of interaction of set that I will tell you, you can write. Otherwise definition here we can write. A definition is something bigger. So what should we do? I tell you definition, then write you. The interaction of set can be denoted using the symbol this symbol. Okay, it is denoted by this symbol. Has definition of, okay, so let's write the definition. The interaction of sets is represented by this symbol. Let's write the definition. Write the definition. Write definition. Okay, the interaction of two sets, I'm repeating once, the interaction of two sets A and B is the set of all those elements which are common to both A and B. I'm telling once again, the interaction of two sets A and B is the set of all those elements which are common to both A and B, or generally in the simple language you can write, in the element which is common, which is same element, we have to represent this element is called as interaction of set. That's over. Okay, right now we have to come to the another set. Okay, we have to erase this one. Oh my god, what happened? Okay, so right now let's take another example. That is the difference of sets. What is the difference of set? Difference of set, this is I think last it is, then our, okay, difference of set is last. Wow, we complete it. Okay, so difference of set is last. Let's see this difference. Okay, difference of set, it is representing by symbol, it is representing by minus. Okay, we see minus in our subtraction. Okay, subtraction. Okay, so this is a difference of sets. Okay, so let me write the definition here only, because when I'm going to tell you definition, that we are going to be lots of things. Okay, so it is denoted by a minus b, or we can say minus only. It is denoted by minus only, generally remember, because always it is going to be minus c or d also. So anything it is going to happen, so we have to write. Okay, let me clear you definition. So definition of this one, that the set of element which belongs to A but not belongs to B. Okay, definition means what? The set of element which belong to A but do not belong to B. Okay, this is our the difference of set. How it is, let me understand by example. Okay, so how we will write it, means that a set of element which belongs to A but do not belongs to B. Okay, let me suppose this is A is given like A, B and C. Okay, and here B is given like B is given C and D. Okay, B is given C and D. In this one I'm telling you, write the difference of A minus B. Okay, this is a difference of A minus B. So in this one it means that we have to write only those element which do not belong in B. So here A is belong, no, A is not belong. B is belong, no belong. C is belong, yes, C is belong. So which element is not belong in B? C is belong, but AB is not belong here. Let's understand. In this one, difference of set means what? Whatever the element in A which is belongs to B but which is not belongs to B, we have to write that one element here. In set A is belongs, no, it is not belongs, so we have to write A. In this set B is belongs, no, B is not belongs, so we have to write B. C is belongs, yeah, C is belongs, so we don't have to write. So this is our definition or example of the definition of difference of set. Difference of set means what? We have to write those elements only which is do not belongs to A. In difference of set, we have to write those elements only which is do not belongs to B. Which is do not belongs to B. Let's take another example. Okay, let's take another example. Let's example number here we can say. Okay, let me tell you. This is 1, 2, 3, and 4. Oh, what happened? Okay, this is 4. Okay, and here it is given. B is given here. It is given here like 3, 4, and 5. Okay, I'm telling you write the A set B. Okay, so in this one whatever the element belongs to B, we don't have to write this because 3 and 4 is belongs to B, so we don't have to write this one. We have to write those thing only which is not belongs. In this A which is not belongs to B. In this one A, and in this one 1 and 2 is not belongs to B. Otherwise 3 and 4 is belongs, but 1 and 2 is not belongs. So this is our difference of set. Okay, I hope you will understand this difference of sets and it is also clear for you. Okay, now right now, so let's take a do this example here. So do this example is given in your textbook also. So A is given here. Okay, so here writing A is given like 1, 2, 3, 4, and 5. Okay, this is 5, this is 5. Okay, don't understand something. And B is given here. B is given 4, 5, 6, and 7. And the question is asking that find. We have to find. Okay, what we have to find? Where to find? Is A belongs to B or B belongs to A? So let's find it out. So first write A minus B equals to, okay, whatever the element is A, is it belongs to B? Yeah, let's see who is belong. 1 is not belongs, so we have to write 1 because 1 is not in B. Okay, right. 2 is also not belongs to B, we have to write. 3 is also not belongs to B, we have to write. 4 is belongs, so we don't have to write. 5 is belongs, so we don't have to be right. So this is the answer. So whatever the element which is belongs to B, we don't have to write this one. Whatever the element which is in A which is not belongs to B, we have to write on those only. So I already written here. Okay, let's write B and 1. Okay, whatever the element in B, we don't have to write. In this one 4 is belongs to here, 5 is also belong, but 6 and 7 is not belongs to A. In B, in the set of B, 6 and 7 is not belongs to A, so we have to be right here 6 and 7. Okay, so this is called the interaction of sets. I hope you will understand, and the next video we are going to discuss our exercise 2.2. okay, so I hope this video is going to be understandable for you, and we will meet another video. Jai Hind.